The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
The first thing we are going to talk about is the relative reactivity of acid derivatives. Now, this class of organic compounds has a very wide or a very varying degree of reactivity going down the group or going from one member to the next. For instance, acetylchloride, which looks something like this compound we have right here, right? I'm just going to quickly draw it out. That's acetylchloride, okay? If you're using systematic nomenclature, you would call that ethanoyl chloride. This compound right here reacts violently with water. It's very, very reactive. On the other hand, another compound, ethanamide, which looks something like this, is relatively unreactive, even in boiling water. As a matter of fact, you need to heat it in a strong acid or a base for several hours on end to actually hydrolyze it. So how do we explain this large degree of difference in reactivity within the same group or within compounds that belong to the same group? So the relative reactivity of this class of compounds depends on two main things. The first one obviously would be the structure of the compound itself, okay? And the second one would obviously be the nucleophile. The nature of the nucleophile that is actually attacking or adding to each and every one of these derivatives to form a new compound. But more specifically for today, we're just going to focus on the structure of acid derivatives and how it affects their reactivity. Now, as you can see, what we have on the screen is pretty much an order of the relative rates of reactivity. And as you can see, acid halides the most reactive, followed by anhydrides, followed by esters, followed by acids.